Hello, Coach Holmes here, and today we're going to be talking about angle bisector and perpendicular bisector. Now we're starting a very new unit, so this is going to be something new to us. Alright, now just a couple of vocab we need to go over real quick. First off is equal distance. Equal distance means that it is the same distance from two figures. Okay, so it's kind of similar to to congruence, but it's a different type. It's basically if I have a distance from two figures and they're going to be the same distance, it's basically saying another way of saying congruency. Basically, it's just another fancy way of saying it. Now, perpendicular bisector is something new. Perpendicular bisector is a perpendicular line that split a segment into two. Okay. Perpendicular bisector is a perpendicular line split a segment into two. So this is one example right here. So if I have a perpendicular line right here, I'm going to have this segment congruent to each other, or at least split evenly, right? This is a definition of perpendicular bisector. That's basically what it looks like. If I have a perpendicular line through a segment, I have two congruent parts for that segment. Now, angle bisector is a little bit different. This time is a ray through an angle into two equal angles. So this time, if I have an angle bisector right here, those two angles are going to be congruent to each other. Okay? So I have two congruent angles that gives me an angle bisector. Now, there's a lot of different things that is unique about perpendicular and angle bisector. And we'll talk about more about this tomorrow when it comes to triangles, but there's some theorems we need to discuss. First off, we have perpendicular bisector theorem. This basically states that a point on the perpendicular bisector is equal distance from the endpoints. Now, what does that mean exactly? So if I have a segment here, and I'm going to draw it in blue, if I have a perpendicular bisector right here, doesn't matter where the point for that perpendicular bisector is. If I draw it out, that's not a very good draw. There we go. These two are going to be equal distance from each other. The green are. Okay? So basically the red is my segment, blue is my perpendicular bisector. And if I draw the distance in green, they're equal distance to each other. From point to point, they're equal distance. Now, the converse of it is basically the reverse of it. So basically, if I have points on endpoint equal distance, from line, then the line is a perpendicular bisector. That's the biggest key. If I have, so basically, if I know that this is equal distance, then it's a perpendicular bisector. So basically, it worked both ways, is initially what I'm trying to say. It worked both ways. Now, angle bisector kind of does the same thing. So there are points on the bisector of an angle. So basically, angle bisector, those are equal distance from two sides. Okay? So basically, so let's say I have an angle right here. Here's my angle bisector. Now if I draw the distance, which by the way, the distance closest to the line is perpendicular, so that's why I have right angles here. These are equal distance from each other. That's what it's going to look like. So just to recap, the angle here in red is my angle. Blue is my angle bisector. So these are congruent. But the distance from the angle bisector to a side are equal distance from each other. Now the converse of it, again, it's just the opposite. Now, two sides are equal distance then it's a angle bisector. If the two sides are equal distance, then it is an equal, let me start over. If it's two sides are equal distance, then it's an angle bisector. Okay, so basically, again, we're talking about something that works both ways. Now, we're trying to solve, we want to solve for GH here. So basically, we're trying to find the distance. Okay, so notice that I have perpendicular bisector. Okay, so if I know that these two are equal distance from each other, then these two lengths have to be equal distance. Because these two lines are, because this segment right here is going to be congruent, side angle side, so I have congruent triangles. So I know that 2x is going to equal to 3x minus 8. Now I just got to solve for x. Subtract 3x from both sides. Negative 1x equals 8. Divide by negative 1. Oh, that should be negative 8. My fault. I forgot the negative 8 down. So negative 8 divided by negative 1 is 8. So if I want to solve or figure out what the distance is, remember, replace the x with 8. 24 minus 8 gives me 16. So GH is 16. And that's how I find my distance. Now, I can do the same thing here. If I have an angle bisector right here, and look, they're both right angles. Well, basically, let me start over. I want to find the distance from GM. I want to find this distance. Now, since these two are equal since, yeah. Okay, so I got an angle bisector here, so that means these two are going to be congruent to each other. So by solving it, I just set them equal to each other. So I'm going to subtract 2x from both sides. 2x equals 12. And all I got to do is just divide by 2. X equals 6. But remember, that's not my answer though, because I got to replace the 4x with 6, or I replace x with 6 to give me 24. Excuse me. So basically, the biggest thing we're trying to do is be able to find the distance when we're given perpendicular bisector as well as angle bisector. But they both uniquely work out the same way because the distance that it makes are going to be congruent to each other. So I just realized that it doesn't have to be side equal side, but that these two distances are going to be congruent to each other because we have perpendicular bisector. So that's my mistake right there. But we can still prove it based on side equal side to be true. Matter of fact, that's probably how we know the theorem works, because we can make side equal side. But, like I said before, these two are going to be congruent because of perpendicular bisector, and these two are going to be congruent because of angle bisector. So just be aware that the distance that it makes after you make perpendicular or angle bisector are going to be equal distance. Thank you, and have a good day.